Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over the performance task for the Smarter Balanced Assessment Course Consortium for grade 11. In this tutorial, we're not just going to go over the mathematical components of the problem-solving process, but we will also go over how to make use of the different tools that you have to use when answering the questions in the performance task. So let's take a look at problem number 1. Now we have the paragraph here that all the questions are based off of. And if you notice, this box right here can be used to alter the size of this field. So if I click on it, you notice that the entire window is occupied by just the text, and then the response section is concealed. If I click on it again, and it reverts back to its original position. If the text size is too large or small, you can use the zoom buttons to alter the size of the text. See there, I'm magnifying it, and then you can also make it smaller. Okay, now let's go ahead and take a look at the problem. Title is speeding tickets. So as you're reading these text right here, um, a lot of the information are helping you to have a mental image or understanding of what the situation is. Okay, so don't take anything for granted. Try and take note of different components of this text. So it says speeding tickets. New York State wants to change its system for assigning speeding fines to drivers. The current system allows a judge to assign a fine that is within the ranges shown in Table 1. So this is Table 1. Notice the title. You want to pay close attention to the title of each graphic that's provided so you don't get confused, okay? So Table 1 is for New York, and these are the speeding fines. Miles per hour, minimum and maximum fine. So between 1 to 10 miles per hour over the speed limit, the judge can fine you anywhere between 45 to 150. Okay, so you have a range of fees to pay. 11 to 30 miles per hour over, 90 to 300, and then 31 or more, 180 to 600. So the judge basically assigns a fine within this range. So um, what how do drivers feel about this? Well, let's go into the next part. It says some people have complained that the New York speeding fine system is not fair. The New Drivers Association (NDA) is recommending a new speeding fine system. The NDA is studying the Massachusetts system because of claims that it is fairer than the New York system. So drivers have complained that they do not feel that this system of fining speeders is fair, so they want to change it. Okay, so they feel that the Massachusetts speeding system is fairer. So this table here, this is table 2, Massachusetts speeding fines. This is the speeding system that they feel is fairer. So between 1 to 10 miles per hour, you are charged a flat fine of $100. And then for 11 miles per hour or more over the speed limit, you would be charged $100 flat rate plus $10 for each additional miles per hour above the first 10 miles per hour. So this is what you're going to be doing in this task. You will analyze the speeding fine system for both New York and Massachusetts. Then you're going to use the data to propose a fairer speeding fine system for New York State. Okay? So in a nutshell, you're going to be analyzing these two to see which is fairer. Now let's go to question 1, part A. It says use the information in table 2 to plot data points for Massachusetts speeding fines. Okay, so we're looking at table 2. Remember I told you earlier when you're referring to data, please pay close attention to the heading so you do not use the wrong data set for your responses. So we're to do two things here. first thing is to plot a point to represent the fine for driving 5 miles per hour over the speed limit. So you have these two buttons here. This button, if you click on it, it says select locations of points. It enables you to add points to your grid. And after you add a point, if you hover your mouse over the point, you can click and drag it all over anywhere you want, okay? Now, if you accidentally put too many points or you do not want to you want to delete a point, you use this deletion button. When you click on the deletion button, it says select an object to remove. So you have a crosshair, just click on the point and the point is deleted. Okay, so we have all the points deleted. Now let's go ahead and start answering this question. So we're going to plot a point to represent the fine for driving 5 miles per hour over the speed limit. So we're going to add point. So please also pay close attention to the legend. Let, notice how the axes are labeled. So fines clearly is your dependent variable and miles per hour over the speed limit is your independent. Think about this as your y-axis and this is your x-axis, and we know y is a function of x. So 5 miles per hour over the speed limit, these numbers here represent the miles per hour. You see this word here, over the speed limit. So 5 miles per hour over the speed limit, this is going to be our x coordinate. So if we are 5 miles per hour over, using table 2, how much is the speeder going to be fined? 5 falls within the range of 1 and 10, so they're going to be charged $100 flat. So 5 on the x, 100 on the y, they intersect right here. Okay, so there goes the first point. Now let's go to the next point. You're asked to plot additional points for each increment of 5 miles per hour over the speed limit up to 45 miles per hour over the speed limit. So we're now going to go in 5 miles per hour increments all the way to 45. Okay? All right. Now, going to 10. If you're 10 miles per hour over, you're still in the first row, $100 flat. So your y coordinate is still going to be 100. Now 15 miles per hour here, for every you get charged $10 for each additional mile per hour above the first 10 miles per hour. Okay? Okay, so before we start graphing, we want to make sure that we really understand what's going on here. So we're going to input some values to wrap our head around the change in fines as the miles per hour exceed 10 miles per hour. Okay, so for 11 or more, something interesting happens here. So let's say we start with 11 miles per hour. What's the fine going to be? For 11 miles per hour, we're going to have the $100 flat fee plus $10 for each additional mile per hour above 10. So $10. How many miles per hour over 10 is 11? Is 1. Okay? If you work this out, you get 100 plus 10. You're going to be fined $110. Okay? Now what about 12 miles per hour? How much fine are you going to have to pay? Your flat fee of 100 plus 10 times how many miles per hour above 10 is 12, 2 miles per hour. Okay? Using the order of operations, 100 plus 20, the fine is 120. All right, now let's jump to 15 because we're to graph multiples of 5, right? So let's jump to 15 miles per hour. How much is the fine going to be? 100, the flat charge plus $10 times the number of miles 15 is above 10, which is 5. Work this out using order of operations. We have 100 plus 50. 150 is the fine. Okay, so hopefully you can see a pattern here. Now let's go from 15 and jump to 20 miles per hour. What's the fine here? the 100 flat plus 10 times how many miles per hour is 20 above 10 miles per hour? It's 10 because 10 plus 10 is 20. So 10, you have 100 plus 10 times 10 is 100. 100 plus 100, which equals $200. That's the fine. Okay, now let's just do one more, and then we're going to use repeated reasoning and examination of the pattern to basically make predictions as to what's going to be happening as we increase our mile per hour above the speed limit by 5 miles per hour. Okay, so for 25 miles per hour, we have the flat charge of 100 plus $10 for each mile per hour above 10. 25 is 15 miles per hour above 10 because 10 plus 15 is 25. Using order of operations, we have 100 plus 10 times 15 is 150, and your charge is $250. So what do you notice happens with the fine as you increase the mile per hour violation by 5 miles per hour? From 15, um, well, let's put 10 in there also. So for 10 miles per hour, we already know that is just 100. Okay, that one is straight 100. So from 15 to 20, how many miles per hour jump did you notice? 50. Sorry, $50 jump. From 20 to 25, how many dollar jump in the fine? 50. Okay, so this is going to be the constant growth rate. Okay, because for every mile per hour, you are charged $10 more after 10. Okay, so for 5 miles per hour is just simply 5 times 10, which is $50. So for every 5 miles per hour you go above 10, you're going to be paying 50 because you're multiplying it by 10. Okay, so from 10 to 15, how many miles per hour is that? 5. So the fine is expected to be $50, 5 times 10. Okay, so let's keep track of how this grows. If you're increasing this by 5 miles per hour each, your fine is going up by 50 miles per hour each, okay? 10 times the growth rate. All right, let's keep that in mind and go back to drawing the points. All right, so based on our calculations, we know that for 15, we have 100 plus 5 times 10, which is 150. And then we're going to graph the x coordinate is 15 and the y coordinate is 150, a point right here. When we go to 20, it's going to go up to 200. That's 100 plus 10 times 10. And you see this pattern right here, the points that we graphed, 25, based on our calculations, was 250. So 25 goes to, let's make sure I do this correctly, 250 right there. And then you notice that there's a linear pattern forming. So you don't have to do all the calculations. You can just follow this linear pattern and then just put in your points right there, following that straight line all the way to 45. Okay? Because your growth rate is for every 5 you run, you rise 50. Okay? Run 5, rise 50, run 5, rise 50, rise over run. That's the slope of this point, this inclination of the points right here. Okay, so if you do this, graph all these points, you get full credit. Note, we're just plotting points. We are not graphing a line. So you want to really pay attention to the instructions that you are provided with. All right, let's look at number 2. It says create an equation to calculate the Massachusetts speeding fine F based on the number of miles per hour M over the speed limit when M is between 1 and 10. So this is another way of saying that the range of M is between 1 and 10. So which table are we going to use here? Table 1 or table 2? We are writing an equation for the Massachusetts speeding fine. Okay, so we're looking at table 2. So if you're between 1 and 10, you have a flat charge of 100. Okay, so we're going to write an equation. The phi f, okay, just click on F. We're creating an equation here, is equal to the flat charge of 100. This is constant. It doesn't change. So that's why if you look at the graph we drew earlier, between 1 and 10, we have a horizontal line. What is the slope of a horizontal line? Is 0, which means it's constant. Okay? Any mile per hour over between 1 and 10 is going to be just $100 fine. So that's why we have the function f equals 100. All right. Okay. Now let's shift gears to the third part. So for part C, number 3, it says create an equation to calculate the Massachusetts speeding fine F based on the number of miles per hour over the speed limit when m is greater than 10. So we are now creating an equation for the second row here, 11 or more. So let's go back to the line, to the point. So what is the equation of a line that contains these points? That's what the question is asking. So we're going to have to do some work to figure that out. But since we have a lot of points, the question is, how many points do you need? At least how many points do you need to write the equation of a line? You need at least 2 points, right? And we have more than enough here. So what we're going to do is just pick 2 points, 10, 100, and 15 and 150, and use that to create the equation for the fine when m is greater than 10 or 11 or greater. Okay, so let's do some calculations here. So we want to use just 2 points. So this point right here and this point right here, that's what we're going to use. The first point is 10 comma 100, and then the second point is 15 comma 150. Now, how do you write the equation of a function given 2 points? You use a point slope form of the equation of a line. Y minus y1 equals m times x minus x1. All right, so this is x1, y1, and this is x2, y2. In this equation, we just need 3 things. We need the point x1, y1, and the slope, m. If you notice, we already have x1 and y1. We just need to find our slope, okay? So how do we find m? M is rise over run. Rise is y2 minus y1 over run x2 minus x1, okay? So let's plug in the values of the points coordinates given here into this equation to find out what the slope is. So y2 is 150 minus y1, which is 100, over x2, which is 15 minus x1, which is 10. 150 minus 100, um, that's 50. And then 15 minus 10 is 5. And then our slope is 10. Okay? Now that we have everything we need, we're going to plug it into this equation. So we have y minus y1. Y1 is 100 equals m, the slope of 10, times x minus x1. What is x1 again? It's 10. X1 is 10, as you can see right here. Okay, now this would be the correct, well, let's get y by itself. We can isolate y, so we can add uh, 100 to both sides. Add 100, add 100, and then you have y equals 10 times x minus 10 plus 100. Now this can be a variation of the correct answer if this graph were x and y. But what do we have here? We have m and f. Okay, remember we said earlier that this is your independent axis, x, and this is your y. Okay, so m is x and y is f. Let's put that in here. We want to make sure that we're using the notation that is presented to us. So we are going to have for y, f equals 10 times, and then for x, m minus 10 plus 100. Okay, so this is an acceptable answer. If you have it like this is perfectly fine. Or you can choose to simplify it a little bit more. That's okay too. You just distribute the 10, and then you have f equals 10m minus 100 plus 100, and then you have f equals 10m. You can also write it like this. This is also an acceptable response. So this is the equation that models the fine you have to pay if you exceed 10 miles per hour. All right, so how do you enter it? It's pretty straightforward. Remember, we have f and m. F is the dependent, m is the independent. So you can enter f equals 10 parentheses. In the parentheses, we have m minus 10. All right, and then just click outside the parentheses to move your cursor outside. Plus 100. That's the first answer. You can use this, or you can just go f equals 10m. Both of them are equally accurate. Okay, so there goes your answer for part 3. Thanks so much for taking the time to watch this presentation. I really appreciate it. Feel free to subscribe to our channel for access to the remainder of the review series. If you have any questions about this presentation or any math questions in general, feel free to include it in the comment section below this video, and we'll be glad to address it as soon as possible. More clips can be found on the mathgotserved.com, so feel free to visit that site. Thanks again for watching, and have a wonderful day.